So to find the acceleration of the boy parallel to the plane, so I like to think of it like this. I'm first going to make all the markings that I need to represent. So going up, oops, this is huge. Going up is the normal force. Going down is the mass times the gram. So whatever is coming this way is mg cosine of theta, and whatever's coming this way is mg sine of theta. So same would apply for up here. We can use this, so we'll have whatever is coming down here, because we also have this force pointing us upwards, but we would still have that sine of theta, which would be that force in that direction. So basically, we have to find all the forces that are going in the x direction, not the y. So it means this cosine is irrelevant, and this normal force is irrelevant as well. So what we would have is that the acceleration equals the mass times the gravity of sine in the x direction of that theta. And we have to say that everything will be going down, but what's stopping it from going down is that force. There'll be that force I, the magnitude of that, times sine in the beta direction, because again, sine is what's going in the x direction and cosine will be in the y direction, and that's the answer for this problem, which is C.